Hey guys, welcome to part 2 of example 5. We're looking at natural logs for part 2, and as you can tell by looking at the pattern, ln of 3 to 6 to 12 to 24, you're doubling every time the power. And so this is an arithmetic sequence we're looking for. We're looking for a common difference, but doubling has to do with multiplication. So we're going to want to rewrite our natural logs in such a way where we can see the common difference. So let's start with a sub 1. And that's just ln of 3. Nothing special there, but once we get to a sub 2, it gets a little interesting because that's really ln of 3 times 2, right? Well, remember here, if we're multiplying the powers, what are their exponents doing? What are their log expressions doing? Well, they're adding. So this is ln of 3 plus ln of 2. Here you can see the addition. That common difference is ln of 2. Let's just do this pattern just 2 more times just to see it a little bit more. Well, 3 times 2 is 6, and I need to now get to 12, which means I have to multiply by another 2. So it's really 3 times 2 times 2, right? That's 2 squared. And that's really ln of 3 plus ln of 2 to the second, but we have power rules, so we bring it to the front. And so notice we've added another ln of 2. And then the next one, right, would be ln of 3 plus 3 ln of 2. And so you can now see that there is a common difference of ln of 2. You always just take whatever the previous one is and then add ln of 2. So let's do part A. Common difference is ln of 2. Part B, we want the 10th term. And so the 10th term, you can think of a couple of ways to do it, but the way I'm thinking about it is I know that intuitively I start with 3 and I keep doubling it. And how many times do I double it if I want the 10th term? Well, that would be 9 times. So it would be 2 to the 9th, right? It's times 2 times 2 times 2 times 2. And so whatever value that gets you, that would be your 10th term. Let's do C, which is the recursive definition. Recursive definition, we must include the base case. So we want to include a sub 1 is ln of 3. And this one's really easy because if I want a sub n, if I want the 10th term, then I would need the previous term. So that's just a sub n minus 1. And what do I do from the previous term? I just add my common difference, and that's just ln of 2. And that's it. Again, I'm going to box that because we want to make sure we understand that. Recursive definitions always have to come with their initial base case. And then D is the explicit definition for this arithmetic sequence. And so that's just a sub n. We'll start from the beginning. So if I start always from the beginning, just like I did in my examples, I start with ln of 3. And I can look at my little analysis here, right? I can see that, hey, ln of 2 is constantly being added, but right here it's adding once for a sub 2, added twice for a sub 3, added 3 times for a sub 4, and that goes into that whole idea that it's plus n minus 1 times ln of 2. And that's your, I'm going to keep doing that. That's your explicit definition. That's it. I'll see you in example 6.